Welcome to another great GLCD tutorial. This time we're looking at compressing pictures. In the previous video, we looked at how we can put pictures onto a GLCD. This time we're going to look at how we can compress that to reduce the overhead on the microcontroller. Let's have a look what we've got. We have got the cow where we left it yesterday. And if I program that where we left it yesterday using the routine called draw PNG, let me zoom in on that for you. Draw PNG, I'm going to place a picture at the location 0, 0, 0. And why I'm just going to do that is we're just going to look how much program memory that used. Now, the reason I chose 110 pixels yesterday by 110 pixels because it just about fitted in the program memory because it filled the memory. It's writing 27,280 bytes as reported by AVR Dude, and the compiler does the same thing. So that is using nearly 90% of that chip. Let me have a look what it says here. It's using 92.75% of that chip. Let me show you an alternative way. Let me just comment that out, and then I'll draw the same picture using a compressed PNG. And how we do that compression, I'll do in a moment. So this time, we're going to compile it using a compressed table. And that table is now substantially less. It's 14,070. Now, I didn't work out that compression. The method I've used, called sliding window, has halved the size of that file because a lot of that file is repeated. There's a lot of white, a lot of single color blue, and the sliding window techniques just optimizes the data held in that table. So how did we go about doing that? Well, from yesterday, we can remember that we used a utility called ImageConverter 565. I opened an image, I scaled the image to 110 pixels, I saved the image into a C file called gcstudio.c, and then inside of our editor, I took that table and then edited it inside of the IDE to just make it into a GCB table. So that's the data. It's very, very similar. I'm just going to pop over it back into my source code to show you that. And here's the original table. If I show you in the IDE, there's a red block at the bottom, and you can see it here in the mini map. There's a small table here, and that's the optimized table, and the size of it does not indicate the amount of data that's in there. It's just it could be wider in the editor. But this is the raw table that came in from ImageConverter 365, and they don't have a utility. They don't have a compression technique. So I've written a compression technique, and then this is the converted table in the mini map, and you can see I've called it Smile Compressed 110 pixels by 110 pixels, and there's a lot of data. There is nothing like what was in the original table. So how does it do that? Well, I wrote a very simple routine. I'll just minimize these here so we can get them out of the way, because I just want to focus on this compressed table. So, compressed data table. I call that from my program at the top, and then it's just going to output a revised table onto the serial terminal, and then we can just paste that into our code. So let me just show you that running before I walk the code with you. So compressed data table, we'll call compressed data table here. On the screen, I'm going to bring up a terminal, and that terminal will connect to the PIC, and it will show us that data. Now, I'm using a particular microcontroller, and the program sets up the serial to allow us to do this. I am not going to show you how to do that. Connect. Clear. And now it's outputting a new table using the old table that we took in from ImageConverter 365, and it's putting it out as a sliding window set of data. All you have to do is cut and paste this from the serial terminal into the program, which I've already done. And you can see, if you look at the top of this program, it says table smart compressed as Word, 110 by 110, and a load of data. And at the bottom, it's got compressed, how many elements it compressed, and the end table. Well, let's look at that inside of the editor. Using the minimap, I can go straight to it. So essentially, what it's doing, it is now compressed that data by saying it found a pixel that was white, or FF, and it found in hexadecimal 6, 7, 8 of them. So that's quite a lot. Then it found a value of E7BF, and it found 1 byte. And you can see then a bit later on, it found the value of 65535, and it found 64 of them, 63 of them. And so what it did, it went through and examined the existing table and output an optimized table. Let's have a quick look at that code. Here we go. Compress the data table. There are some variables it uses. Read in the object width and object height, same as we did in the previous video. It outputs a serial header, which is what you've seen in the terminal, and outputting the header table and the width and height. It then walks through the table, outputting it in a different format. So it says, read the pixel in, put that in a variable called pixel RGB, and it's got a store called compressed, a variable called compressed pixel data. And if it's changed, it knows to start doing the count. If it has changed, it will also output that previous value. So it essentially outputs the sliding window by saying if the current pixel is not the same as the compressed pixel data, just output it on the screen, and it essentially puts out on the screen the pixel data and how many were in that compressed window. So it will go FF, and a number. It will go a pixel color and a number. And that's what it's doing. And it's got a comma in between it with some hexadecimal formatting. Does some counting, very simple. This section here just puts a new line in when necessary. And that is it, because all that it does at the bottom is terminate that table. Read existing table, output a new table, job done. Then what I did was then put that new serial data into my code here. It's exactly from the serial terminal. Oops, so sorry. So let's have a look at how we then draw that, because it's relatively simple, because we now know the format. So in here, I'm just going to comment out that, draw compressed PNG. Let's find that in the source code, and here it is. Well, we've got a table that's compressed. It reads in the number of elements that are in there, and that's for element 0. It reads in the object width and object height, as it did previously. It now knows that the rest of the information comes in pairs. The color, or the pixel, and the number of pixels. The color, and then the number of pixels. So it essentially says, what is the compressed pixel data, and how many are in that sliding window? That variables are called compressed pixel data and compressed window. And it just increments through for the number of elements divided by 2 minus 1. Why is that? Because they're in pairs. And we've got the object width and object height in our code, therefore we just deduct 1. The moment we see that, we then say repeat for the compressed window, and we output to the XY position the compressed pixel data. How do we control the X and Y location? With a variable called compressed counter. And it's quite simple. We can mod that, use mod on the object width to guess the X position, and then we can just divide the compressed counter by the object's width again, but divided by it to give us the Y position. So we've got a sliding window decompressor. Let's see that operation. Go back to the camera. Now that's the red box it drew. It drew a red box because I wanted to ensure I was getting the full extent of the program, of the picture being shown in the program. Voila. The delay is a 3-second delay that I put in my program. And we have got a program that is now half the size of the original. So that is how you can compress a picture in GCBASIC using a sliding window algorithm to halve the size of this particular chip. This particular chip is 32K. Other chips are larger and smaller. So this technique is quite useful. It is very dependent upon your picture. A picture of a landscape with thousands of colors in it will not compress. A picture with very simple colors and repeated colors will compress highly. So the sliding window methodology is very easily implemented and saves a lot of program memory. Please subscribe to this channel, like this video, and enjoy.